All right, so what we're looking at today is quadratic factorization, but quadratic factorization by way of factorizing by grouping. So we have to start there. Ideally, we're going to need four terms to factorize by grouping, and our problem is that we need to get our quadratic form, ax squared plus bx plus c, from that three-term form to a four-term form. So let's start by looking at general factorization by grouping, and then we'll see what that looks like with quadratics. All right. So it's a lot of examples. Let's get through it. The first one I want to look at is ax plus ay plus bx plus by. And I'll put a second question right alongside it. 3p plus 3q plus, I feel like most of us have seen this before. Let me write this down. 5pr plus 5qr should be there. All right, now when we factorize by grouping, what we're looking to do is to have, let's say, pairs of terms that have something in common. So if we look to these pairs of terms here, if I go ax plus ay, there's an a in common here. They both have a as a factor. If I look at bx and by, they both have b as a factor. Now, can you rearrange? You can definitely rearrange, but again, if you're rearranging with a view to putting terms beside each other that have something in common. So I'd put ax beside bx and ay beside by if I were to rearrange, right? Now, we can factor as is. If I factor and I say, okay, what's common to these two terms? It's going to be a. And what remains when I divide ax by a, I get x. And if I divide ay by a, I get y. All right. Now, for the second pair of terms, what's common to bx and by is going to be b. I can factor b out. When I factor b from bx, I get left with x. I'm going to factor b from by. I get left with y. Now, again, you get to this point, you can go further because you now have two terms. All right. You have this term here and this term here, and there is a factor common to both these terms, and that factor is x plus y. And we can factor that out. And if I factor x plus y out of this term here, I get left with a. And if I factor x plus y out of this term here, I get left with b. So now we have a complete factorization by grouping. This is what we're looking for. This is a process, and it repeats itself, right? So let's look at this question here. Same idea. What's common to these two terms would be 3. Now, before we get there, could we have rearranged these terms? The answer again is yes, but we need to put terms beside each other that have something in common. So here I'd use 3p and 5pr. I'd have those beside each other. And then, of course, 3q and 5qr. Some people might argue that 1 is something that you can factor out of all terms. I would agree, but it doesn't advance your cause or your case in terms of getting to this final form here, which is a product of two binomial terms. So we can rearrange if we need to, but in this case, we're okay to just factor. So what's common to 3p and 3q is going to be 3, and what remains is going to be p plus q. What's common here to 5pr and 5qr? It's not just 5, but 5r. And what remains is p plus q, right? And we can factor these two terms here a bit further because they both have p plus q in common. And what remains here when I factor p plus q out of this term is 3. When I factor p plus q out of this term, it's going to be 5r. And so we're good, right? All right. Now, what I will do, we'll try maybe two more of these, and then we'll look at a bit more some of these questions that have quadratics in them. So let's see if we can get this done. We should be able to have a clear screen now. So for question number 3, we're going to look at 2mn plus 2mp plus 5n plus 5p. And over here, for question 4, we'll have 4x plus 8y plus 3x squared plus 6xy. Now, having said that, The process is the same. We look for what is common. Do the adjacent terms have something in common? If so, we're good. If not, we might need to rearrange. Currently, we're good because we have something common here and we have a term common with these two. So when I factor here, what is common to both 2mn and 2mp? Now, you could argue, but more than 2 will also have m, right? And what remains when we factor 2m from 2mn is just n. And what remains when we factor 2m from 2mp is just going to be p, right? We're there. We're comfortable. Again, what's common to these two terms is going to be 5, a plus 5. And what remains is that n plus p. And we can complete the factorization by pulling out the common term to both these expressions. And we'll end up with n plus p times 2m plus 5. And we should be good. That's all right. That factorization is perfect, right? Let's finish off on this side. What's common here is going to be 4 for these two terms without rearranging. And what's left is x plus 2y, all right? Finally, on this side, what's common is going to be 3x. And what's left, let me shift this over a bit, is x plus 2y, right? We're almost there. What's common again between these two terms is x plus 2y, and what's left is 4 plus 3x. So quick 4 examples. Now, what does that mean for us and quadratics? Well, let's look at a couple of quadratic questions, right? Yeah, we're at question number 5, all right? What if the quadratic is 4 termed, right? It's x squared plus 3x plus 2x plus 6. It's not the standard quadratic form, but with 4 terms, you can factorize by grouping, right? So let's factor by grouping. We can't do this with 3 terms, but with 4 terms, we're good to go. So what's common to these 2 terms? Well, you'd argue x is common, and you'd say what remains? X plus 3, right? And we're comfortable there. Makes sense. What's common to these 2 terms? You could argue a positive 2, and what remains? X plus 3. Same process that we're used to. We're going to factor out that x plus 3, and then what remains is x plus 2. Completely factorized because we had 4 terms here, but not only 4 terms, but more specifically, the 4 terms that we had 2 terms in the middle that both had something in common with the first term and the last term. In that, when we had 3x here grouped alongside x squared, there was an x in common. If we had put 2x here, it would have still been an x in common. We have 2x grouped with 6. They both have 2 in common. If you shifted 3 over here and rearranged, they would both have 3 in common. So it could factorize because the 2 middle terms had something in common with both the first term and the last term. And that's the trick. That's essentially what we need to have happen in order for us to factorize quadratics, right? So let's look at one more example like this before we look at what quadratic factorization is going to look like for us when we have 3 terms. All right, so one more 4-term quadratic, which is not the standard form we're used to. What number were we at? Memory serves. I'm pretty sure that might have been 5 before. 5, yeah. All right, so let us do number 6 if we can. All right, number 6. What if our quadratic is 6y squared plus 9y plus 8y plus 12? 4 terms, so we'll meet that criteria. Can we factor? Well, we can factor if the 2 middle terms have something in common with both the first term and the last term, right? So does 6y squared have something in common with 9y? Well, yeah, they both have what looks to be 3y in common. If I rearrange this and put 8y here, would they have something in common? Yeah, they both have 2y. Likewise, 8y and 12, what do they have in common? Well, 4. And if we did 9y here instead, does 9y and 12 have something in common? You'd say yes, 3. So this will work. We know for a fact it's going to work, right? So let's factor. All right, so what's common here? We said it already. We can factor out a 3y. What remains here is going to be 2y and a 3 here. Now, to be fair, we always want to get this term back in brackets over here, so I'm just going to put it down. This is what I want to get back, right? What do I multiply by 2y to give me 8y? Oh, that's just plus 4. And you can check to see if it works. 4 times 2y, 8y. 4 times 3, 12 in business. So what remains? We're going to factor out 2y plus 3, and that leaves us with 3y plus 4. We're good to go, right? I think maybe one more. I feel like we need one more under our belt for comfort, right? Again, this is number 7 for us. It's x squared plus 7x plus 10x plus 70. Now, this only works, again, if our two middle terms have something in common with the first term and the last term, right? What does x squared have in common with 7x? X. What does x squared have in common with 10x? X. Does 10x have something in common with 70? Yes, a factor of 10. Does 7x have something in common with 70? Yes, a factor of 7. This is going to work for us. It has to work because the criteria is that the two middle terms must be factors or be able to have a factor in common with either the first or the last term. That's it. It makes life easy, right? So let's factor real quick. What's common to these two is going to be x. What's left? X plus 7. All right. I want this bracket back. I'm writing it back. All right. Now, if I have x plus 7 here, what multiplies x to give me 10x? It's just going to be 10. And then 10 multiplies 7 to give me 70. So when I factor now, x plus 7, x plus 10. All right. We should be comfortable with that. Now let's get into what we came here to get into, which is the quadratic factorization itself. All right. Let us scroll on a bit. Let's make some space. And we need to remember what it is that we need to make a quadratic, one that can be factorized, right? So I'm pretty sure that was 7. I'm going to write 8. If I'm incorrect, that is life. All right. I'm going to write that we're at option 8 or question 8 rather. Let us go with x squared plus 7x plus 10. Now, this is a 3-term quadratic. The form that we're used to, this is the quadratic form. Is it the form that we can factorize by grouping? No. In order to factorize by grouping, by this point, you'd have recognized that we need 4 terms. We only have 3 established here. We need to rewrite this, right, as x squared plus some term in x plus some other term in x plus our 10. This is the heavy lifting. And again, for it to factorize by grouping, these terms must have something in common with 10 and x squared, but they must add to 7x. Why? Because we don't want to change the value of our quadratic. If it adds to 7x, kosher, good, we're almost there, but it also has to have something in common with both 10 and x squared, our first and our last terms. Cool? All right, now to accomplish this, we're going to multiply our first and our last term by each other. So I'm going to get 10x squared, and then I'm going to find the factors of 10x squared that just so happen to sum to 7x. Let's see if we can find those factors. We could use 1x times 10x. That would work. Or negative 1x times negative 10x. We could use 2x times 5x, or we could use negative 2x times negative 5x. And I've written out all of the possible factors and considered the signs, because if we have a positive term here, the only way to get a positive term is to multiply a positive by a positive or a negative by a negative, right? Now, do any of these sum to what we want? Well, 1x and 10x when summed give us 11x. Negative 1x and negative 10x when summed give us negative 11x. Negative 2x and negative 5x when summed give us negative 7x. But I'm sure you already know and notice 2x plus 5x give us 7x. So I could write this as x squared plus 2x plus 5x plus 10. And in that way, I can now factor by grouping. Again, does it matter if I wrote 2x first or 5x first? The answer is a quick no, but because the process was such that whichever we choose, they both have something in common with x squared and 10, where x squared and 2x have x in common, x squared and 5x have x in common, 5x and 10 have 5 in common, and 2x and 10 have 2 in common. So doing it this way, where we've rewritten our quadratic, allows us to factorize by grouping if we ensure that the middle term sum to 7x in this instance, and that they have something in common with the product of the first and last term. So let's factor. This now becomes par for the course for us. What is common between these two? We already said it, x. What remains? X plus 2. I have to get this bracket back over on this side, so I'll just write it immediately. And I simply ask myself, what times x gives me 5x? And you can check it. 5 times x, 5x, 5 times 2, 10. We're almost done. Factor out that x plus 2, and what's left is x plus 5. Love it. Light work. All right. I think we have time for one more. We're pushing it. All right. One more, one more, one more, one more. All right. Let me see if I can create a page for that one more. All right. We're here. What number were we at? The memory's horrible. I feel like it's 8. We're at 8. All right. Let's go to 9. Almost there. This is it. This is the last one. All right. Let us go 6x squared. Let me make sure that's the right thing. Plus 5x minus 6. Plus a 5x minus 6, right? Same process. We need to rewrite this as a 4-term expression, 4-term quadratic. All right, and to do that, we're going to multiply the first by the last term. 6 times negative 6 is negative 36x squared. And we need the factors here that sum to 5x. We could use, let's write down the factors. But importantly, this is negative. So one of the factors is positive and one must be negative, because the only way to get a negative product is to multiply a positive term by a negative term. So I could go negative 1x times a positive 36, or vice versa. 1x times a negative 36x. Right? We could go, what else? 2x times 18x, negative 18x, or negative 2x times 18x. We could go 3x times negative 12x, or negative 3x times 12x. And by now, I'm pretty sure you know what option we're going for. Or we could go 4x times negative 9x, or negative 4x times 9x. And you're looking for the option that sums to 5x. Now, it's not a situation where you're going to have to write all these out at all times. You're going to get comfortable enough where you'll be able to pick up on which product works for you. And in this instance, it's going to be this product here. And so we can write this as 6x squared minus 4x plus 9x minus 6, because these two, when added, give you 5x. And when multiplied, give you negative 36x squared, which is a product of the first and last terms, right? So let's factor. What's common here is just going to be 2x. What remains here is just going to be 3x minus 2. And this is what I want in brackets, so I'm writing it back immediately. And I'll ask myself, what times 3x gives me 9x? And that's a positive 3. So what I end up with is 3x minus 2 times 2x plus 3. Gentle people, done heavy lifting today. And I'd have anticipated that you'd have worked ahead of me. You'd have paused where you needed to pause and kind of just worked on the answer to get yourself to a point where you can check your answer against what I have. We've completed what basic quadratic factorization looks like. Our next step is going to be to talk about a difference between two squares, and then completing the square. Probably we'll have its own separate video. So don't forget to like and subscribe. Give us some support. It allows us to do more videos. Allows me to do more videos. That also was interesting that I added that. But hopefully you're benefiting from this and looking forward to seeing you in the next one.